A slingshot launches a rock into the air with a velocity of 75 feet per second. Its height in feet t seconds after it is launched is given by this function. A, find the average velocity from 1 to 2 seconds, and B, estimate the instantaneous velocity at 1 second. So let's go ahead and figure the average velocity from 1 to 2 seconds. In order to do that, I need to know the distance it traveled from 1 to 2 seconds. So first of all, I'm going to find its height at 1 second by putting 1 in for t. And as I substitute that in my function, it looks like I have 80 minus 16, which is 64 feet. Now I'm going to compute the height at 2 seconds, which is just going to be 5 plus 75 times 2 minus 16 times 2 squared. So that's going to be 155 minus 64, which is 91 feet. So if I want the average velocity from 1 to 2 seconds, I'm going to figure out how far it traveled from 1 to 2 seconds, which is going to be 91 minus 64 divided by the time elapsed from 1 to 2 seconds, which is 2 minus 1. And when I compute that, I get 27, and our units are feet per second. So the average velocity from 1 to 2 seconds is 27 feet per second. Now, as we work on an estimate for instantaneous velocity, I am first going to find the height at 1.1 seconds. Now, in order to do that, I'm going to grab the calculator and put in 5 plus 75 times 1.1 minus 16 times 1.1 squared. And it looks like for that height, I get 68.14. So I'm going to take the difference between the heights at 1.1 and at 1, so 68.14 minus 64, and I'm going to divide that by the differences in time, which is 1.1 minus 1. And when I do that, I get 41.4 feet per second. I'm now going to find the height at I'm going to go for 01, and putting that in this function, I get 5 plus 75 times 1.01 minus 16 times 1.01 squared, and it looks like that gives me 64.4284 in the calculator, and I just need to know the distance traveled, and so I'm going to subtract 64 from that, and then I'm going to divide that by the differences in times, which would be 0.01, and on this interval from 1 to 1.01, I get an average velocity of 42.84 feet per second. Now I look in the 10 decimal place and I see that I have definitely changed things here. So now I'm going to actually compute the height that I'm going to go ahead and do it at 1.001. You could do it at 1.005, or I'm just deciding to do this closer by moving out one more decimal place here to the 1000th place here. Put this in the function 5 plus 75 times 1.001 minus 16 times 1.001 squared, and I get 64.042984, which I will then take and subtract 64 so that I can see how far it's traveled on that interval. Divide that by the differences in time, which is 0.001, and so for the interval from 1 to 1.001, I get that the velocity is 42.97 feet per second. Since I'm working on accuracy to 1 decimal place, and I see that in the tenths column I have changed in that step, I'm going to go ahead and compute another one, and I'm going to just do 1.0001. So on this interval from 1 to 1.0001, I'm going to take the function and put that in 5 plus 75 times 1.0001 minus 16 times 1.0001 squared, and I get 64.00429984. So I'm going to subtract 64 from that, and then divide that by the difference in the times, which is 0.0001, and I get a velocity of 42.998 feet per second. So now I can see to 1 decimal place. I am going to estimate my instantaneous velocity to be 43 feet per second.